relation, so we've already seen it, we've already looked at the characteristic of it, but we're gonna explore it in more details. Okay? So we said that the general formula of an exponential relation is y equals what?
Y equals
AB to the power of x, where b represents the base, which is, it has a name. So it's not the base, it's your, starts with an R, and I roll my R's, ratio. So it's your common ratio. Okay, so your base is your common ratio. Yeah. So in this example, in this lesson, we're going to look at exponential growth and exponential decay. Okay? So if you look at this one, it's exponential growth. You always go from left to right. When you're looking at a graph, you always move from left to right. Okay? Moving from left to right, what can you tell me about this function? Horizontal, and then increases fast. Right? So that's why it's called an exponential growth. Okay? If I'm looking at the one on the right, it starts as decreasing fast, then it flat. Okay? So that's why this is called horizontal exponential decay, and that's why this is called an exponential growth. Okay. Now, if you look at the equation, can you look, so this is y equals 2 to the power of x. This is y equals 0.5 to the power of x. What is the difference here? Okay, but yes, so this one is a whole number. Is this whole number greater than 1 or less than 1? Greater than 1. How about this decimal? Decimal could be 2.7, right? But what's special about this decimal? It's less than 1. Okay? So, and that's why this is an exponential decay, because your base is between 0 and 1. And that's why this is an exponential growth, because your base is greater than 1. So when your base is greater than 1, then the relation exponential growth. When your base is between 0 and 1, then the relation is an exponential decay. Okay? No matter what the base is, it could be 0.2, right? So if you have, let's say, y equals 0.2 to the power of x, that's a decay. If you have y equals 0.9 to the power of x, it's a decay. But the minute that my number is greater than 1, so if I have y equals 1.37 to the power of x, guess what? That is a growth. Right? What if it's negative? It's still a growth, but it's a flip. Well, we're not going to talk about the negatives here. Okay?
Wouldn't it be a decay though?
It would be a decay. If I'm talking about this,
Yeah.
it will be. It's just, no, actually, it will be.
How would it be a growth if it's
It will be like this. It will be decay.
Yeah.
No. No. I mean, ooh, I don't want to erase this.
Yeah, because you said anything that's...
Yeah, but if I have negative 1.37 to the power of x, I'm going to have a reflection in the x-axis. So it's going to look like this. But we're not going to cover this here, but let me show you. So it's going to be a decay. It'll be like this. Okay. Well, if I have y equals 1.3, 7 to the power of x, it's going to increase.
Also, it's like a reflection.
It's a reflection in the x-axis, as I said, right? But it's going to become a decay, okay? But again, we're not going to talk about reflections here, not in this course. Okay, so you don't need to worry about the name. All right, let me erase this so people who are looking at this, they don't say, what are these values, where did they come from? Now, so that value of b, whatever it is, if it's 2 or if it's 0.5 or it's point whatever, if it's greater than 1, we call it the growth factor. So if the question's asking you what is your growth factor, you know that you're looking for that base, okay? So you know that you're looking for that base, which is in this case, my growth factor is 2, okay? If the question is asking you for a decay factor, right? Again, it's going to be the base, but in this case, your base is going to be between 0 and 1. So here is the graph on Desmos, and then we're going to look at the x-intercept. Okay? So I'm looking at the x-intercept. What would be my y value? What would be the value of y for the x-intercept? What would be the value of y for the x-intercept? The value for y. So if I'm looking at the x-intercept, no matter what the graph is, right? So no matter what the graph is, okay? If you're looking for the x-intercept, let's say this, okay? What's the value of y here? 0. What's the value of y here? 0. So anytime you're looking for the x-intercept, that means the value of y is 0. Okay? So let's look at the graph. So let's go here, and let's go here, and let's make it two to the power of x. Okay, so y-intercept, sorry, x-intercept. So when is my graph intersecting the x-axis? Let's zoom in, because you're going to see that it's flattened. You see that it's almost touching, but is it ever going to touch? So if I actually do this, I'm zooming in to the flat side. Look at this. Is it touching? No. Is it ever going to touch? No. No. Not unless you have transformation. Not unless I actually move the whole graph there. Okay? So the minute that I go and say, okay, 1 second. Trying to get this to work for me. So the minute I go and say, okay, add or subtract 2, then yes, you'll have an intercept. But I have transformation here. How do I do this? See, now you have an x-intercept. Okay? But if you don't have the transformation, if you don't have that subtract something, then you won't get it. Okay? Okay? How about for the 0.5 to the power of x? How about if I graph y equals 0.5 to the power of x? Do you think I'm going to have any x-intercept? No. Right? I can zoom in. Right? Look. Right? It's flat, but it's never going to touch that. Okay? So for both graphs, unless I have transformation, I have no x-intercept. because no matter what value you plug in for that, you're gonna get 0.0000003, 0.0000523. I don't know, right? So your answer is always gonna be y equals 0.0000 something. Okay? Where it's not 0, it's close to it, but it's not. Okay?
So the value has to be more than 1 for it to intercept?
What do you mean? It won't intercept the x-axis.
It won't unless you subtract it.
Unless you have a translation down or up. So this would, because look at this. 0 equals 2 to the power of x, right? That's for my first equation. So the y is equal to 0. Okay? I'm going to have to find a value of x that would make this 0. So on your calculator, do 2 to the power of whatever number you want. What do you get? 2 to the power of what did you choose?
2.
And you got 4.
Yeah.
Right? So it's not 0. What did you pick? 2 to the power of what, Liam? Anne-Marie, what did you pick? 2 to the power of what? What did you get? 5. 2 to the power of what? How about picking it?
60.
2 to the power of 16?
2 to the power of 4.
Okay, you got 16. Can someone do 2 to the power of negative 4? Yeah.
1 over 16.
1 over 16, which is what in decimal? Okay. Can someone do 2 to the power of negative 7? Times 10 to the power of negative what? Negative 6. What did you get? Which is what?
7?
Negative 7. Which is 7.8 times 10 to the power of negative 3. That's 0.0078. Okay? So no matter what number you're going to plug in, positive or negative, you're not going to get 0. You're going to get close to 0, as you can see, but you're never going to get to 0. Okay? So even if you plug in 2 to the power of negative 7, right? You're going to get 0.0078. Okay? It's never going to be 0. Okay. Now, what will your y-intercept be? So to find the y-intercept, let x equals to 0. Anytime you're finding the intercept, you're going to let the other letter equal to 0. Okay? So, if I let x equal 0, let's do that. If I have y equals 2 to the power of 0, what do I get? 1. So my y-intercept is 1. Okay? Let's use the other equation. Y equals 0.5 to the power of 0. What do you get? 1. Okay? So my y-intercept is 1 for both of them. Again, this will change once we have initial value other than. Okay? But in this case, I don't have any transformation, right? So my y-intercept is going to be if you look here, your y-intercept for both of them is at what? Okay? You guys see that?
Yep.
All right. All right. So use the table of values to answer the question below. They gave me just x and y values, and they want me to answer them. First thing is asking you for the first ratio. So what do you do to find the first ratio? Divide. Right? So remember, you're going to go 3 divided by 1. Okay? 3 divided by 1 is 3. 9 divided by 3. 27 divided by 9. 81 divided by 27. Is this relationship exponential?
Yes.
Yep.
How do you know that? What's constant? Thank you. Don't say it's constant because I don't know what's constant. Okay? You have to say that the ratio is constant. Because it could be the first difference that's constant. I don't know what you guys found. Okay? So, it is exponential. Yes. The relationship is exponential because the first ratio is constant. Now, we know it's exponential. So what is your general formula for exponential?
Y equals A to that.
So y equals ab to the power of x. What does a represent? In this case, it's 1 because that's my initial value. Right? Remember that whatever x is 0, that's your initial value. Okay? So it's 1. Now, what would be your base? 3, because that's the ratio. Right? So I can write this as y equals, do I need to include that 1 here? And then 3 to the power of x, or can I just write 3 to the power of x right away?
Yeah.
Yes. Unless it's like if it was 100, then I have to say 100 bracket 3 to the power of x. Okay? But if it's 1, I don't need to include it. Okay? So, state the equation of the relationship. I did. It's right here. Is that good? Now to graph, I have to graph this, so the highest number is 81. So let's go up by 10 again. And it was 0, 1. So 0, 1, 1, 3, 2, 9, 3, 27, 4. So you look at this. All right. Okay, so we graphed it. Okay, are we good with this? Any question about this? Should be easy, right? Okay, after you find your first ratio, okay, after you found your first ratio, you were able to find your graph. Your equation, you were able to graph. Okay, let's look at this example. So a small garden center propagates tulip bulbs. The gardener begins with 100 bulbs. Each bulb produces several new bulbs. 3 of these are kept for the next round. Write an equation to represent the number of new bulbs. So what's happening here? Should we read the question again?
Okay, so 100 would be your base because they start with 100.
Would be my base or would be my initial value?
Or initial value.
My initial value. I'm starting with 100. What's happening with 100?
It's,
So each bulb produces several new bulbs, so I have new bulbs,
yeah.
but 3 of them are kept for the next round. So 3 from each bulb is kept. So I'm starting with 100, okay? I can't draw 100, but I'm gonna draw like 1, 2, 3, 4, okay? Now I have 100 of them. Not only 4, I have 100. From each one,
3.
I'm gonna keep 3.
Yeah.
So if I started with 100, for the next round, how many will I have? Huh?
Okay, hang on. A small garden.
So how many bulbs is each one producing? 3. So if 1 became 3,
So 1 to the power of
3 to the power of not 100,
1.
depending on how many rounds you have.
Oh. So there's 1
So-
round. There's 3 rounds. So 3 to the power of 3.
No,
No, we don't know how many are produced.
we don't know how many rounds we have,
Yeah,
but we know we're starting with 100.
right.
Each one's producing 3. So if I have 100, produce 3, how many would I have after the first round?
It doesn't say producing 3.
Yes, it does. You're keeping 3.
You're keeping 3.
Yeah. So you started with 100.
Right.
Each one's producing 3, or you're keeping 3. How many would I have? 300. Right? Right?
Right.
Now, each one of this, I'm going to keep 3 again.
Oh, God.
Now, do you think I'm going to draw all of this or not? How many do you think we're going to have in the second round?
900.
Okay, let's see what happens. So, let's see why this is happening. So, we're going to start with our initial number of bulbs, which is 100.
Right.
What's my growth factor here?
3.
Okay, you're going to multiply by the growth factor for each round. So, let's do that. For round 0, I have 100.
Right. Round 1.
For round 1, I have 100 times 3. Now, if I take this round, the second round, and I have to multiply by 3 again, right?
So 300.
So instead of writing 300, I'm just going to go 100 times 3, and then multiply it by 3 again. Okay? So I'm taking my answer from here, and I'm multiplying it by 3. I just don't want to, I want to show you something. I want to show you a pattern.
Okay.
Okay? For the next round, I'm going to take this answer, and then I'm going to multiply it by another 3.
Okay.
Now you see the pattern?
Yeah.
Okay. How would I write my equation? So let's say if I had 4 for the next round, what would it be?
100 times 3 4 times.
Times 3 times 3 times 3 times 3, right? So how would I, instead of writing it like so many times, how can I simplify this? So what would I write here to simplify?
So 3 to the power of x.
So this one's 100 times 3 to the power of 2. And then this is going to be 100 times,
3 to the power of 3.
and then if it's n, it will be 100 times what? 3 to the power of
Huh? 4? What's
n. It's n. N number of rounds.
N?
Right? If it's 4, it will be 4. If it's 5, it will be 5. If it's 6, it will be 6. If it's 10, it will be 10. Right? So it depends on how many rounds I have.
Yeah.
So what's my initial value here?
100.
What's my growth factor?
3.
Does this look like, to you, does this look like y equals ab to the power of x?
Yep.
What is your a?
100.
What's your b?
3.
Remember I told you, it just, if your initial value changes, then this is where A is going to be different than 1, right? And in this case, I'm not starting with 1 bulb, I'm starting with 100 of them. Okay? So A is my, sorry, the general formula, I should have wrote this here, I wrote it there, I don't know why. So this is the general formula. A is
100.
initial in this case, yeah, it's 100 in this case, but it's the initial value. B is the growth or decay factor. And y is the value after x periods of exponent growth. So the equation for this question is y equals, now you can say it, 103 to the power of x.
X or N?
It could be x, it could be n, whatever you want to call it. X is the general in this case.
So would it matter, like,
It wouldn't matter unless I specify I want. Okay, suppose you have, now we're going to look at another type of equation. Never gets easy.
it's gonna explode. Yeah.
Okay, so if you know what your ratio is, what your common ratio is, it's easy. But the minute that they give you percentage, you can't just use the y equals ab to the power of x. Eyes on me, please. So we have two other equations that we look at, which is y equal, again, a, and then 1 plus I to the power of x, and y equals a 1 minus I to the power of x. Okay? So these are also exponential functions, but we use these functions whenever they give us a percentage. Okay? So if they give me a percentage, I use this. And this is for growth. So if something is growing, then I use this one. And this is for decay. So if something is decreasing in value, depreciating in value, I use this one. Okay? So I'm going to look at this question. So you see, how am I going to use that equation? So suppose you have $500 in the bank, and you deposit it into a savings account that pays 2% interest per year. Find the equation that models this exponential growth. So what's the $500?
That is your initial value.
That's your initial value. This is how much money you have right now. Okay? So that represents your A. Is your money going to increase or is your money going to decrease?
Increase.
It's going to increase. So because this is a percentage, then I can't use my original function. I have to pick one of these.
Yeah.
Which one would I pick?
The first
The first one, because it's increased. I'm going to get more money, right? So I have to use the first one. So y equals, instead of A, what do I replace A with? 500. 1 plus. Now here's where you have to be careful. I is your percent, but it can't be in percent. So you can't write 2. What's 2%?
0.02.
0.02. How do you find that?
2 divided by 100.
So you always have to change it to the decimal. Okay? So that's 1 plus 0.02 to the power of x. So if you look at this, now after I do my math, and I add whatever is inside the bracket, does this now look like this to you? Does it have the same format?
Yes.
Yes. but I couldn't right away go to it. I had to use another equation first before I can get to it. Does that make sense to you guys? So anytime you read anytime it's money and then you're getting interest, you're gonna use the growth. If you're depreciating in value, so it's going down, then you're gonna use the minus. So find the amount of money you will have after 3 years. How would you do that?
You would make x equal to 3.
That's right. So you see how you have an x here? You just go y equals 500, 1.02 to the power of 3. And then all what you have to do, plug this in the calculator. Okay? Plug it in the calculator and tell me what you get.
$530.60.
So after 3 years, you have $530.60, right? Does it make sense? Yes. You started with 500, your money increased about $30. Makes sense, 2%, it's not that much of a percentage, right? So don't forget your therefore statement. After 3 years, I have $530.60. Are we okay with this?